Okay, let's try this question. Determine the coordinates of C and Q here, and then we've got a line that g of x is minus 2x plus 3. So we know this line that goes through Q right here, the x-intercept of Q, that's what it is. They told us that this A and C C is a reflection of A across this dotted line. So if it's minus 5 here, it's got to be minus 5 over here. And it's right on the y-axis. So A, we know what C is. Just because of that, it must be 0 and minus 5. And to get the x-intercept here, we just let y equal 0. And if we let y equal 0 here, we're going to subtract 3, divide by negative 2. X is 3 halves. Just let that equal 0 and solve it. You'll get x is 3 halves. And that is, that's Q. That's what Q is there. Now let's determine the equation for the axis of symmetry of F. Well, just by symmetry, if it's 4 over here, and if you went 4 right over to this other side all the way to 0, it must be right in the middle. It must be x equals 2 just by symmetry. What about E here? What about E here? How can we figure out E? Well, you can see that this is minus 1 and 0. That's a point here, right? Well, if that's, and we know that x equals 2 here, if we go 3 to the left by symmetry, it must be 3 more than 2. It must be 5. So it must be 3 on either side. You see 2 and 1 makes 3 all the way to F. So this must be 3 more than 2. And we know that this is 2 right in the middle. X is 2 by symmetry right here. So we've got E is 5 and 0. That was a little bit of thinking and was using the idea of symmetry alone.